Fourth grade, lesson 8.4 is multiply a fraction or a mixed number by a whole number. Let's see what we've got. Our essential question is, how can you multiply a fraction by a whole number to solve a problem? Same kind of idea as the previous lesson. Now we're just kind of moving away from modeling it, but it sounds like they're also going to put mixed numbers in with us, and so we'll see how to solve that. Christina is planning a dance routine. At the end of each measure of music, she will make 1 1/4 turn. How many turns will she make after the first 3 measures of music? So if we look at this, one measure takes 1 1/4 turn for one measure, right? She's going to do that for, I covered it, for 3 measures. So 1 1/4 for one measure, 1 1/4 again for another measure, and 1 1/4 again for another measure. We're adding that together 3 times. 1 1/4 times 3. Will she make more or less than 1 1/4 turns in 3 measures of music? She'll do more, right? Because each time the measure of music goes by, she's doing more. So more. What operation will you use to solve the problem? Well, I could use repeated addition, but the shortcut for that actually ends up just being multiplication. So I'll go with that. And so here we ended up with 3 times 1 1/4. I just wrote it backwards, but as you know, multiplication is commutative. It can go in whichever order as long as that's the only operation. So what I'm going to do is write 1 1/4 as a fraction. Remember when we did that and we had 1 was the same as 4/4? Well, okay, let me back up. We have 1 1/4, right? And these are cut into 4 equal pieces. So I'm going to take this 1 and cut it into 4 equal pieces. All of them are still there. And then we have the 1/4 as well for a total of 5/4. That's what we're going to do here. So when we're working with multiplying fractions, we do need to change mixed numbers back into improper fractions. And I even mentioned, I think we covered this in the previous lessons a while back, that what you'll find the pattern you're doing is you're taking this whole number, multiplying it by your denominator because you're really just saying how many pieces you're cutting it into, and then you're adding how much is in this numerator because you're taking that 4 and then adding 1 more to it. So if you just multiply, add, you'll get your improper fraction. 1 times 4 is 4, plus 1 is 5. Of course, the denominator stays the same. And then I can use the same skill as I did in the previous lesson. 3 times 5 is 15. Denominator stays the same. They want me to write the product as a mixed number. So now that and that's the thing with multiplication. You'll get super fast at this, though, over the next couple years. The first thing I'd have to do is if I have mixed numbers, I've got to convert them back into an improper fraction. And then when I'm done, I'm expected to convert that improper fraction back into a mixed number. They're going to walk us through it here. But as you know, I had mentioned before, fractions are just a number over a number. So really, I'm just looking at this division problem. I'll do it that way, too, after I go through this. So we need 15/4. 15/4 spread out. Well, it takes 4/4 to make a whole. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. There's 2 wholes. 9, 10, 11, 12. There's 3 wholes. And then 13, 14, 15. That's not enough to make a whole. There's a total of 3/4 there, though. So I ended up with 1, 2, 3 whole, and 3/4 of a little bit more for a total of 3 3/4. If I wanted to just use the conversion tool, 15 divided by 4, we would go 15 divided by 4. The closest I can get to 15 without going over is a 4 times 3, which is 12. I end up with 3 left over out of 4. Same thing. So Christina will make 3 3/4 turns. This will probably take some practice. There's a lot of pieces being put together here. Let's ponder this question. If you multiply 3 times 1/4, is that product, the answer, going to be greater than or less than 3? Think about it for a moment. I'll draw a picture. Let's model 3 times 1/4, or let's go ahead and write it out. 1/4 plus 1/4 plus 1/4. As a picture, I have a whole pizza, but I'm only using 1/4 of it. I have a pizza, but I'm only using 1/4 of it. I have a pizza, but I'm only using 1/4 of it. If I put these three pieces together, am I going to have more than more than 3 full pizzas? No, I'm not, right? Let's say I put these together. Take from there, take from there. I don't even have 1 whole pizza, right? So putting together 1/4 only 3 times isn't going to be anywhere near 3. So I'll say no, it's much smaller. I'll just put it smaller so it fits. It's smaller than 3 or less than 3. Now they want us to explain how we can tell that 3 times 1 and 1/4 is greater than 3 without finding the exact product. Well, if I just picture in my head, I have 1 whole and 1/4 of another one. If I'm going to do that 3 times, I have more than 3 already. And then I have the extra there, 3/4 extra there. So I already have 1 whole pizza. 3 of those is already going to be more than 3. So there's 1 whole pizza and a little more, 1/4 more, and that's multiplied times 3. So 1 whole pizza and a little more, and then 1 whole pizza and a little more again, and then 1 whole pizza and a little more again. So we have more than 3, right? That whole number definitely changes things compared to this one. This section is taking you through what I had explained before and why it works, where you multiply then add. 8 and 1/5 as a fraction, we want to write it as a fraction, an improper fraction, that upside down snowman thing. Really, this is 8 and 1/5, 8 and a little bit more, 8 and 1/5, 8 and a little bit more. And I need to cut this 8 pizzas into 5 pieces because this amount is cut into 5 pieces. Well, I want it to match. So I'm taking these 8, slicing them into 5 pieces. I still have all of them. So basically 5/5 is what I'm doing. I better write it that way. Maybe that will be less confusing. 5/5, and that's what I'll put down here, 8 times 5/5. And we learned that 8 times, to do this multiplication, that is 8 times 5, which is 40. I still have this 1/5. And when I put that all together, 40 plus 1 is 41/5. So this part was cutting this pizza into 5 equal pieces, 5/5. 8 times 5 is 40/5, and now I can do the addition. You'll just get used to after time. You won't have to do all these steps. You'll recognize the pattern. I take these 8, cut them into 5 pieces. I still have all 40 of those pieces. 8 times 5 is 40. Then I add the 1 from the 1/5 to it, the 1/5 to it for 41/5. So I just kind of get it stuck in my head that I multiply, add, bring it to the side, I used to say. So bring it to the side. It's my numerator. 8 times 5 is 1, plus 1 is 41. That is my new numerator. Multiply, add. Because when I'm multiplying, I'm cutting it up. Now I have 40/5, and then I add 1 to it. Then I'm going to practice changing an improper fraction, that upside down snowman, where the bigger number is on top of the little number. How do I change that back? That one I think for you guys will be even easier because you're just taking the idea that a fraction is simply a number over a number, which is a division problem. So I will do 32 divided by 5. 32 divided by 5. Which is what they wrote here for us. And 5 does not go into, 5 times nothing will give me that. I'll have 3 and 2. 32 divided by 5, well, 5 times 6 is 30. That's as close as I'm going to get. I will have a remainder of 2. So I have 6 from here with 2 remaining out of the 5 that I was dividing. 6 2/5. And if you wanted to check it and bring it back practicing this, it's going to come out back to that again. 6 times 5 is 30, plus 2 is 32. Denominator remains the same. So that's how you work those in and out of being improper fractions. Sometimes you need the mixed number to be an improper fraction, and sometimes you need the improper fraction to be a mixed number, and you have to be able to go back and forth, and you will become very fast at that. All right, we'll try this. They want us to do 5 times 2 2/3 as the product as a mixed number. So before we can multiply these, we need to convert this into an improper fraction. 2 2/3 as an improper fraction. We can cut these 2 into 3 equal pieces, these 2 whole pizzas into 3 equal pieces. 2 times 3 is 6. Those 6 pieces are still there. Add the 2 from this 2/3. So 2 times 3 is 6, plus 2 is 8/3. And just in case you need to see that conversion happen to 8/3, sometimes our brains just need to see it. I'm going to draw 2 whole and 1/3 of another. 2 wholes and 1/3 of another to represent 2 full and 2/3. Oh, sorry, that's 2/3 of another. My bad. 2/3 of another. Now I'm going to go ahead and just cut these ones that were uncut before into thirds. That's what I'm doing when I say 2 times 3. I had 2, and I cut them into 3 equal pieces each. So I have 1, 2, 3, 4, 5, 6. 2 times 3 is 6. That part just represents me cutting them up. So there's 6 now pieces. And then the 2 from this one left over. So 1, 2, 3, 4, 5, 6, 7, 8 thirds. That's what's happening. So when I multiply this, I'm cutting these pieces into the size I need and then adding the one that was still a fraction. Multiply 2 times 3, 6, add 7, 8. That's your new numerator. Now that I have it at 5 times 8/3, I can use the skill I had from the previous lesson. 5 times 8 is 40 thirds. And now that is my answer. Only they said, write that as a mixed number. Okay, no problem. This is simply a division problem. 40 divided by 3. 40 divided by 3. 3 times 1 gives me 3. That's as close to 4 as I can get. 3 times 3 gives me 9. That's as close as 10 as I can get. And I will have 1 out of the 3 I was dividing left over. 13 1/3. We're just going to get a lot of practice of converting mixed numbers into improper fractions and improper fractions into mixed numbers. They want me to explain why my solution of 5 times 2 2/3 equals 13 1/3 seems reasonable. Well, this is 2 and a little more. 2 whole pizzas and a little more. 5 times 2 is 10, so I'm going to have at least 10, and then there was a little more. And so 13 is a little more than 10, and that 2/3 3 times would be the rest of it. So you can use your whole numbers that you know to kind of get an estimate of what's close. I'm expecting if I had 2 pizzas and a little more, and now I'm bringing that 5 times. 5 times 2 is 10. I'm going to get more than 10. That's why it's reasonable. The way I wrote that is 5 times 2 is 10, and 5 times 2 2/3 means 5 times 2 and extra. I guess hopefully that makes sense to you. That's how I went ahead and explained it. Does this one make sense or nonsense? To find 5 times 2 2/3, Dylan says he can find 5 times 2 and add it to 5 times 2/3. Does that make sense? Well, if this is 2 2/3, is that the same as 2 plus 2/3? If I put those together, is that the same? 2 plus 2/3, 2 and 2/3, right? I have that. if I multiply this one times 5 and this one times 5, having pulled them apart, and then I put them back together again, we've been working with pull apart, put back together again, Humpty Dumpty, right? You broke it apart, pull it back together, distributive property. It seems like it should make sense. I think it can work. Let's try it. 5 times 2 is 10. 5 times 2 thirds, well, 5 times 2 is 10 thirds. Okay, and I'm looking at 10 whole, then 10 thirds, but that's an improper fraction, so it's really hard for my brain to know how many whole pieces is that. I know it's more than 1 because it's an improper fraction, but how much more than 1, right? Let's do 10 divided by 3 to find out. 10 divided by 3. That would be 3 times 3 to give me 9 with 1 left over, 1 out of the 3 left over. So this is the same as 3 and 1/3. Now I'll just add the 10 to that. Oh, and 13 and 1/3, yes. So it makes sense. I could pull apart the 2 and also the 2/3, multiply this part by 5 and this part by 5, and then put it all back together again, and that works too. Okay, well, this is certainly something that's going to need some practice, right? But if you're still not clear on it, don't worry, you're not clear yet. You are going to get this. We're going to do 2 times 3 and 2/3. In order to multiply mixed numbers, we have to convert them to an improper fraction. We can do 3 times 3 is 9 plus 2. 9 plus 2 is 11, and we get 11/3. So we're doing, instead of 2 times 3 and 2/3, we converted that to 2 times 11/3. I'm going to draw this picture for you, so if you're still struggling with how I'm doing this, why I'm doing this 3 times 3 plus 2, that'll help your brain make sense of it. Okay, here this is as 3 and 2/3, 2 out of the 3. I'm going to cut it into 3 equal pieces because that's my denominator. I will cut these into 3 equal pieces. So here goes that. Oops. 3 there, 3 there, 3 there. 3 cut 3 times. 3 times 3 is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I add the 2 that are over here, 10, 11. 11/3. 3 times 3 was this one. Then I add 2 for 11. Okay, well, now I use the scale from before. 2 times 11 is 22. And now that I've completed my multiplication, I'm needing to convert this back into a mixed number because that helps everybody's brain envision how much we're talking about. This is 22 divided by 3. Luckily, you're all very good at your division. You're really quick at it. 3 times 7 is what gets me as close to 22 as possible, and I'll have 1 out of the 3 left over. 7 and 1/3 is my final answer. Let's look at this next one. Write the product as a mixed number. Oh, this is already a fraction, not a mixed number, so I don't have to do this conversion here. I just need to do my multiplication. 6 times 2 is 12 over 5. Now, that is an improper fraction, and remember, they want it converted back into a mixed number. We'll just do our division there. 12 divided by 5. Well, 5 times nothing is going to get me the 1. 5 times 2 puts me at 10. That's as close as I can get to 12 without going over. I will have 2 out of the 5 left over. So there it is as a mixed number. 12/5 is the same as 2 whole pizzas and 2/5 of another one. Let's look at this one. 3 times 2 and 3/4. We're going to convert this to an improper fraction. We can't multiply our fractions without converting them first. This is 2 times 4 is 8, plus 3 more, 9, 10, 11. 11/4 is going to be my fraction. Here's the visual real quick. I had 2 whole here, 3/4 of another. I'm going to cut this 2. I'm going to cut them into 4 pieces because I want that denominator the same. So 2 times 4 is 8. Here I am cutting them up. 4 pieces there, 4 pieces there. 1, 2, 3, 4, 5, 6, 7, 8. So 2 times 4 is 8, plus these 3, 9, 10, 11. Now I'll use the scale of 3 times 11. That is 33/4. And now I need to convert that improper fraction, because it's more than one, much more than one actually. We need to convert that back by dividing. 33 divided by 4. Well, it's not going to do that one. 4 times what gets me close to 30 without going over? 4 times 7. Good thing we've been working those multiplication facts, right? That leaves us with 2 out of 4 left over. The answer is 7 2/4. A lot of steps involved to do the one thing. Like I said, you'll get very fast at these over the next couple years of converting them into improper and back out of. Okay, here we go again. 2 times 1 and 5, 6. 1 times 6 is 6, plus 5, 7, 8, 9, 10, 11 sixths. We had one whole pizza. We cut it into 6 slices. That's 6, plus the 5 that were in the other one where some was missing. Now we'll do the multiplication. 2 times 11 is 22 sixths. That is an improper fraction. It is more than one whole pizza. How many more? I'm not sure. I need to divide to find out. 6 times what number gets me as close as possible to 22 without going over? 6 times 3 is 18. 6 times 4 is 24. That's too high, so we're going to go with the 3. And we get 3 left over. 3 out of 6 left over. So my answer is 3 whole pizzas and 3/6 of another one. There may be a few of you who are ready to go on a Think Central where this all makes sense, and that's great. You go right ahead. If you feel like you're ready to tackle this on Think Central and you don't need me anymore, go ahead. If you feel like you need a few practice ones, I am going to continue this video with a few more practice ones for you so that you can get the hang of it. We'll look at number 5. This is 4 times 5/8. 5/8 is not a mixed number. It is already just a fraction. No whole numbers combined with it, so we can just go straight to the multiplication. 4 times 5 is 20. We get 28ths. All right, but that is an improper fraction. They want our answers as mixed numbers, so we need to convert it into a mixed number. Improper fraction means more than one. I just don't know how many more than one. 20 divided by 8 is how I will find out. 8 times nothing is going to get me to 2. Okay, what about 20? 8 times 2 is 16. 8 times 3 is 24. That's too high, so we're going to have to stick with 2. We subtract and get 4 left out of the 8 that we were dividing. So this is 2 and 4/8. That one's done. You may want to try pausing on this one and trying it to see where your error is at. If you make any errors, or to build your confidence, if you get it right, to go, oh, I do get this. So go ahead and try this. All right, let's see. This is not a mixed number. It's a fraction already, so I don't have to do any conversion there. Multiply. 6 times 5 is 30 twelfths. That is an improper fraction, meaning it's more than one. I just don't know how many more than one, so I will divide 30 divided by 12. 12 times 2 is 24. That's as close as I'm getting. Well, here, I guess I should do that step first, since we're just getting the hang of that. Okay, now I'm on 30 divided by 12. 12 times 2 is 24. And 12 times 3 is way higher, so that's not going to do me any good. 10 minus 4 is 6. So 6 left out of 12. 2 and 6/12 is the answer to that one. This one, though, is my mixed number, so I do need to convert that. Multiply these, then add that answer to that for your new numerator. 2 times 2 is 4. Plus 1 is 5. Keep your denominator. And then I have to multiply that times 3. Okay. So 2 and 1/2 is the same as 5/2. Multiply by 3. 3 times 5 is 15 halves. Now that is the answer, but it's an improper fraction. more than 1. I just don't know how many more. 15 divided by 2 will tell me how many more. 2 times nothing gets me to 1. Too big already. And 2 times what number gets me as close to 15 as possible without going over? 2 times 7 gives me 14. I have 1 out of 2 left over. So my final answer is 7 whole pizzas and a half of another one. 15 halves is the same as 7 and a half. I hope those extra practice ones helped you out. If you're needing extra help still, let me know. We'll practice a few more.